failure mode occurs and make modification of that design. And then, of course, we go through the application for the STC. Being in Canada, we go through Transport Canada first, and then through the bilateral agreement, we actually come to the FAA to transport to get an FAA STC on our product also. A couple of highlights from the last couple of years. We actually got the STC for the hydraulic accumulator. So that piston for both the York and the Hydrodyne model accumulators are now approved, both the polymer piston as well as our V-seals. In 2018, a couple of things that we started, and this actually has more slides that we're going to touch on, but it is the ozone nose landing gear package for that one, as well as the flaps and the seat rollers. We just completed the annual on Sandy's airplane in July of this year. And at that point in time, there's over 528 hours on the products that have been installed in that aircraft. And we have over 60 locations installed in that aircraft, both certified locations as well as some that are currently in development. Ozone nose landing gear. Couple of differences between the ozone and the Weevil. We currently have an STC package out on the Weevil. We're now working on the ozone. The upper and lower bearings in the ozone are not like they are in the Weevil. Both the upper and lower bearings incorporate the centering cams. And based on the type of our polymer and how it works, these are actually areas that at this time we don't see an application. So being able to replace the lower bearing and the upper bearing of the ozone is not a candidate for us. One of the areas that we're seeing the biggest challenge is actually in the collar, the steering collar, and the bushing installation. On the Weevil, for example, the bushing, the metal bushing is pressed into the steering collar, which means it's a fairly easy replacement for us. On the ozone, the bushing is actually heated onto the outer cylinder, and the steering collar has hard anodized journals that run on that bushing. So in this scenario, one of our leading concepts is to actually apply a polymer bushing to replace the bronze. The trick with this is that we're going to need to bond that bushing in place more than likely. And that does pose some challenges for us with certification. We're going to need to find the right type of adhesive, and we're going to need to do bond strength tests to demonstrate the integrity of that bond. Another concept that we're thinking about, and this one actually is going down on the list as a possibility, is to leave the bond in place. Having said that, one of the conditions has to be that the existing bronze bushing is free of damage. It needs to be no scores on the OD if this concept's going to work. But in this particular case, we would look to open up the idea of the steering collar. A couple of challenges that poses: it's a one-way retrofit because we would machine out the steering collar, which means if you ever incorporated this change and wanted to go back, you can't revert back without a new steering collar. The other challenge with this is that we would fundamentally change the dynamic interface between the collar and the cylinder. And this is where we do see a lot of challenge with Transport Canada coming. Because now we would take a polymer bushing and actually run it dynamically on the aluminum journal on the steer or on the outer cylinder. So this one actually for us is probably an unlikely candidate. So we're putting a lot of resources right now into that bonded bushing concept. Another area that we're testing is the flaps. Fairly early on, the decision was made to go with a stainless steel material, 316 stainless. And after about 175, 200 hours of flight testing on Sandy's airplane, we started noticing some deformation on the rollers themselves, where they were actually deforming around the tracks. That caused us to look hard at going to the mechanical properties of the material. We identified ToughMet3 as a replacement material. It's in general a tougher material, harder material. It has more durability than 316 stainless. And we've just recently installed the first set of what I'm calling Gen 2 rollers on Sandy's airplane. And now we're at the stage of flight testing. One thing I wanted to touch on here is that going with a grease-free, lubrication-free flap systems there does need to be corrosion protection on the tracks themselves. We did notice that in the absence of grease and oil, surface corrosion started on the track material. And what you're actually seeing here, that brownish goldish tint, is a corrosion inhibiting compound called Corvan 50. It's manufactured by Zipchem. This particular material is applied through an aerosol can. It dries, it has a waxy type of texture to it. And since putting that on, we haven't seen the reemergence of any type of surface corrosion. Another area that we started working on this year, a month ago or so now, is the seat rollers. Interestingly enough, you've got an aluminum roller on a stainless steel sleeve on a steel bolt, and in the aircraft maintenance manual, it actually says do not lubricate. We understand the concept of why you wouldn't want to put grease or oil in the rollers in an area where you would see a lot of sand and dust and grit. But you've got metal on metal, and it just is a perfect environment for wear to occur. We've actually got some prototype materials that are being manufactured right now. The concept would be to take the aluminum roller itself, open up the ID, and press one of our polymer bushings into it. As an option, we're also offering, or will be offering, the stainless steel version of the sleeve that actually runs inside of the polymer bushing. This product, based on our airworthiness assessment, does not require certification based on how it's actually called up in the manual for adjustment and replacement. We're actually going to launch that one as just a repair to the existing account.
Nick, your mic for some reason.
Hello?
Thank you.
That's
actually-
to add that the reason we did the seat roller thing is because the seats tend to stick even with those Easy Glide, because one roller wears more than the others, and then the seat becomes unbalanced. And you get the seat dragging on the Easy Glide roller, and once you get all the rollers exactly identical, which this will do,
That's right.
and the seat rolls like it was sliding on air.
Yes. Yeah, this is going to be a complete recovery of any wear and stiction in the rollers. And this actually works even in the absence of the Easy Glide system. It's an overall improvement to the existing rollers. Wanted to touch on, and this is, it's a learning process for us, talking about best practices for bushing installation. And also touching a little bit in the upcoming slides about the difference in how the material fails and what it could lead us to as part of an investigation. This is actually a break block bushing that was found cracked. And the type of failure that you see here, there's no deformation to the material around the fracture faces. There's no extrusion or movement of the material. The wall thicknesses are all intact. This type of failure in one of our polymer bushings is indicative of an installation problem or an installation issue. One of the best ways, because all of these bushings are actually installed with an interference fit, that's what keeps them in place, is freezing them. Not necessary to freeze them, but it's highly recommended that they be frozen or cooled down before installation. And that cooling method can happen in one of two ways. The third option, liquid nitrogen, is absolutely not recommended. This material in contact with liquid nitrogen, it just completely upsets the material. But a standard freezer works. Overnight minimum, 24 hours or more, even better. You can leave it in there for days at a time if it just happens to be there. Or you can also expose it to dry ice for up to about 2 hours. 3 to 4 hours is better. The other piece of pushing these bushings in is the preferred method is an arbor press. It keeps absolutely perfect alignment between the bore you're pressing the bushing into and the bushing cylinder itself. An acceptable method is any alternate method that makes sure that that alignment is there. The other element to pressing the bushing in is a relatively smooth, continuous driving force as you're pressing it in. The example at the bottom might seem extreme, but it's a perfect example of misalignment between the bushing and the housing, and that inconsistent driving force trying to get it in, where chances are high there that the bushing is going to be damaged. This area is another failure mode of the material. This was actually a condition that was found in Sandy's airplane on Saturday. Interestingly enough, it is an area that we've seen problems with in the past. That particular bushing came out of one of the lower torque attachments to the piston. And originally, when we went to redesign this area, we did have very similar failure modes. What we did at the lower locations is we lengthened the bushing. But because of the constraint of the lug design, we were only able to achieve about 15 to 20% increase in the bushing length. In the upper location where it attaches to the cylinder, we doubled the length of the bushing. We did originally see this type of overload failure in both locations. Doubling the length of the bushing increases the bearing area, reduces the bearing pressure, and the problem is solved at the upper location. Clearly, the problem is not solved at the lower condition. We've just started the investigation to understand the loads better at this lower condition, but at this point in time, it looks like we may simply have a location that the material can't handle the loads that are actually going in, and we really don't have an option to increase the bearing area anymore because of the geometry of the lugs. So we're still early in the investigation stage here, but in Sandy's particular case, he put the metal bushing back in.
Yeah, 3 of them were fine and 1 was extruded and damaged.
Right.
It's a little bit unconclusive, but it's still an area of concern.
That's right.
Are all the lower lengths configured like that? Or is that some of the airplanes?
From what we've seen, these are all of the lower attachment points to the piston. There is one case in the upper where we have seen, I think it was only one airplane out there, where instead of having the solid lug, this was actually, it looked like it was machined out, milled out in the center. But this is a typical design for the upper torque link attached to the cylinder, and this is a typical interface of the piston interface with the torque links.
We had that problem on Joel Stubbs' airplane. Joel?
I think I've got a solid lower. I don't think it's got.
I think he's got a solid up, I don't think it's solid.
I think they're all, we're only solid on the upper. But anyway, Joel's, we had that problem, and we went back to Aerostar Aircraft, and apparently there are just a few airplanes made that way. They probably had an issue as well, and then they made the full length.
Yeah. I'd be curious to know though, if you could double check that and let us know, I'd be really curious to know what you've got
I'm
more.
sure I've got a solid lower.
Well,
Because that spare gear had a gear lower like that, and I couldn't use it. And when I got to use it, solid, which matches mine.
Mine are open like that, so we'll look tomorrow.
Okay. And the solid lower would work with your
If it's well, just in general terms, any solid lower at the piston level that's like this, then yeah, that gives us the envelope to double the bushing length if we need to in that area. Curious to know what you've got in your airplane, but every one we've seen so far is actually in this configuration.
I'm gonna bring him out to the airport tomorrow, so I'll report back when I get back.
Okay, Jimmy.
Yeah, Nick, Don Smith told me that he had one airplane in his shop, and when he jacked it up, the bronze bushing was frozen on the bolt, and the oleo wouldn't extend. Don, you remember that?
Yep.
And that's the problem with the bronze, is you can't get grease in there, and that's the reason we wanted to change it. And we will fix this problem somehow.
It may take a new polymer.
Yeah, we need to develop a polymer that has carbon fibers embedded in it that will take a higher pressure, and I think that will probably do the job. But we thought we had it fixed, and we had several hundred hours on my airplane, and looked like it was perfect until all of a sudden we could see. What Ron said about wash the airplane for a pre-flight. I was just cleaning the airplane, and I just put my finger down there and felt, what's this? And the bushing had actually started to extrude out of the lug, and I could feel it. I mean, you could see it too.
Yes.
But
And the
what happened? Why? Why would it
and
go
when?
300 hours without any problem at all, then suddenly a problem? I think it's only probably a couple of harder landings than normal, or extra braking, or put extra load on that, but that is absolutely the highest loaded place on the gear.
Right.
And that's why Aerostar Aircraft had to come up with 2 torque link upgrades, because successively they had problems with the tremendous load there.
Right.
During braking and on landing, when you got that great torque.
And that's actually a big part of the investigation that we're doing, is to try and categorize the loads that are in this area. Couple of things working against us from an engineering point of view is the geometry of the gear. It's a single wheel, it's offset. So any type of settling loads higher on one side than the other, crosswind landings that's going to impart a higher side load, that just drives a lower or a higher load into that lower torque link that needs to be reacted. So we're disappointed that we're seeing the failure. The other piece of it that we need to factor in is that this airplane went through an annual in July. And our annual is more than just a normal annual, because it is a flight test vehicle for us. We do actually pull it apart. We take measurements of the various locations. We want to understand how it's wearing overuse. And this condition did not exist, or didn't even begin to exist in July during the annual. Yet a couple of months later, during a washdown in the airplane, the condition exists. So going back through the flight logs and understanding as much information as we can is all part of the investigation that we're doing.
Nick, you don't think that could have been from taking it apart to measure it and put it back in?
No, we don't think so. It was taken apart. We went in with a bore gauge to get the actual size on it, profile the idea of the bushing, and put it back together. Again, following the AMM. The good thing is that the person that did the annual is a reasonably new mechanic to us, but he's got over 20 years experience working for the airlines. So is it possible? It is possible, but I think it's a very, very slim possibility at this point. A couple of new things, and this is getting into wrapping it up. We are working with fuel cap washers. We went back and forth internally with our airworthiness engineer as to, did we need to get an STC? No, we don't need to get an STC. Do we need to get any certification? The final verdict is yes. We don't need an STC. We do need what's called a PDA. It's a lower level of certification, but the good thing with that is that once we get the Transport Canada PDA approval on it, FAA approval of that is automatic through the bilateral agreement. I know a number of you are already flying this, and if anybody is interested in it ahead of the cert, we would absolutely provide it, but we do have to go through the paperwork motion on this one. A couple other areas, we're working on other platforms. Baron and Bonanza, we've already gone a fair bit down the road of putting brake bushings into this.
What's the de-icing?
That is actually what drove us to the need to do a PDA. There was 2 things that we need to demonstrate compatibility with. One is avgas, which we've already done, and the other one is the de-icing fluid, and it's a material compatibility test that we need to run to make sure that anything in those fluids won't adversely affect the polymer. We've got the King Air lined up, and actually one of the more exciting things for us is that we're actually engaged with one of the large OEMs for landing gear. We are exploring the possible application of our polymer in a transport category, a FAR Part 25 aircraft. It's a staged evaluation of our product. We've gone through the first level of testing with them. The material worked well, both from a wear rate point of view, as well as not having an adverse wear effect on the mating metal part. And we're just starting discussions with them about doing a full-scale test. It is a larger aircraft. The application we're talking about is about a 10-inch diameter bearing. So that's about all I can see on that one, without possibly getting myself into too much hot water. But it looks like we stand a fairly good chance of getting on a Part 25 airplane. And new polymer development. We do recognize that there are physical limitations, both with the existing polymer that we have and with the applications based on the geometry of the landing gear, especially when we're talking about retrofitting out existing product. That really puts us in a fairly tight box about what type of envelope we can use. So we do recognize that we need to get polymers that are better in higher temperatures, better at higher pressures. And that generally is the direction the industry is heading in. You know, one thing I want to touch on here with that quote at the bottom is that the Embraer E170, 175s actually got certified with a 10 and 12 year TBO in the landing gear. The industry is driving for landing gear utilization on condition and really improving those times. And that's where not having to grease and using polymers really adds benefit there. And that's it. Almost holding on time.
Very good, thanks. I got one question on braking. You know, the disc brakes get incredibly hot. So temperature on those is not an issue?
Temperature is not an issue. It was a concern early on, and I'll let Sandy expand on this, but he was basically flying around with an infrared gun and
Measured temperature?
measuring temperatures. Yeah. That's a lot of, because of the environment that we're in, that's a lot of how we develop that data. We have a lot of empirical data behind us. We have a lot of experience with the polymers and applications, but sometimes you just got to put it in an airplane and put it through the motions and see how it works.
I figured that the brake bushings would be a problem. I mean, because of heat, but there's been absolutely no sign of it. When Nick said we took our airplane down for the annual this summer, we pulled the one gear leg off the airplane and took everything apart, every single bushing, all the trunnion bearings, the link bearings. We couldn't find anywhere, and that's at 500 hours of flying. So we're pretty confident, and I was surprised to see those brake bushings are in perfect condition. Because you can't put grease or lubricant in there. But the heat that gets into the brake block, that basically anchors the brake to the lower piston blade.
Pretty intense.
It just doesn't get hot enough to cause damage to the bearing.
Good. Good to hear.
Thank you.
We have a